All right, number 15 says, predict the charge on that a calcium ion would have. So this is just something you need to kind of memorize. 1A, charges are +1. All right, so mainly the metals, lithium, sodium, potassium, rubidium. These are going to have a +1 charge because these are going to form ionic compounds. This is going to form covalent compounds. So for right now, you don't really need to know the charge of hydrogen. 2A is +2, and 2A includes calcium, so these elements are +2. These want to lose one electron, so they can be noble gas-like. Basically, they lose their valence electron, and then their core electrons are noble gas-like. If you take sodium, for example, it has 11 electrons. When it loses one, it has 10, and it is like neon. Okay, so these ones are going to be +2, because if you take calcium, for example, and it loses 2 electrons, it's going to have 18 and be like argon. 3A is +3. This generally only applies to aluminum, okay, because it has to be a metal, so 3A is +3, sorry. 4A tends to form covalent compounds, so we skip it. Then we get to 5A. So if you look here, nitrogen would have to lose 5 electrons. Well, that's a bad example, but nitrogen would have to lose 5 electrons to be like helium, okay? But if it gains 3 and goes from 7 to 10, it'll be like neon. So 5A likes to be -3. The metals, which are over here, tend to form cations or positive ions. The nonmetals, which are over here, tend to form negative ions because they're closer to forming noble gases in that way. 6A is -2 because if oxygen, for example, gains 2, it'll be like neon, it has 8, then it'll go up to 10. And 7A, like fluorine, likes to gain 1 and be -1. So metals in 1A, 2A, and 3A, so over on this side of the periodic table, like to lose electrons and be positively charged. Nonmetals, over on this side of the periodic table, like to gain electrons and be negatively charged. They're all trying to be more noble gas-like. Because this specific question asks about calcium, which is right here, the answer is +2 because calcium is in 2A.